Welcome to another programming exam solution tutorial, and we're looking at the AQA 2017 paper 1 Predator Prey. Today we're going to be looking at MagicRabbits. Before you think I'm going mad, let's have a look at what's been bothering me right from when I first saw this code. So, I really hope you are at least familiar enough with the code that you can see what's going to happen. When a warren has 99 rabbits in it, there's a bit of code that means a new warren is created. It's in a random location, and that new warren has a random number of rabbits, but they come from nowhere. And they're certainly nothing to do with the rabbits from the old warren. They're completely new, and they're a random number, and crucially, they're not from the old warren. This bothers me. You can't have magic rabbits appearing. So, solution, dead simple. When we create a new warren because of a full warren, we simply take a set of rabbits from the old warren and we stick them in the new warren. Simples. But it's OOP, so getting the data in and out of the two instances of the class is going to be a bit of a pain. It's not too bad, but we just need to be careful. What I like about this problem, even if this one doesn't come up, if you can solve this, this is like the key way of getting data in and out of an object. Right, before we do that, let's have a little look. So I've got a simulation set up, and all we're going to do is work our way through until we see one of these warrens create a new warren. We've got 1, 2, 3, 4, 5. It's the default, and there's a few foxes about, but they tend to sort themselves out. So I'm going to hide the detail, and let's go on. Hopefully this won't take too long. Oh, 1, 1 looks promising. So we've got 1, 1. We've lost a warren somewhere, so we're down to 4 warrens. 1, 1 happens to be on 99. There isn't a fox in sight, so that should spawn a new warren. 1, 2, 3, 4, 5, 6. Oh, we've had 2 spawned, eh? 1, 2, 3. Oh, sorry, I missed one before. So we had 5 before, and we've now got 6, and effectively these 32 rabbits in this warren have come from absolutely nowhere. Even if these rabbits were breeding like rabbits, in one time period we wouldn't be able to produce 32 rabbits. Plus, this is going to sit at 99 forever. I suppose it might go down a smidgen because of death and old age and stuff like that, but then we'll reproduce back up to 99. This is not a good simulation. So, let's sort this out. Key things that we need to consider, by the way, just to check. Everyone happy that what we're doing? Taking the rabbits from that 99, and when we create the new 38, I would have taken away 38 from the 99. So, most things that we're going to play with here are in the warren class. First thing that makes sense, you need to get the rabbit from the full warren. So we'll create a new method, seems to make sense. It's a sort of getter, if you like, which will grab an array of rabbits, which I'm going to call transferred rabbits. And we're going to return that out of there. So if it gets called from simulation class, that will actually give us the transfer rabbit straight out. Need to be careful when we do this that of course we need to destroy the 30 or 38 whatever rabbits we take from there, so that we don't accidentally leave the 99 left in. The other thing we need to be really careful about is that we also update rabbit count, because rabbit count is what actually produces the number on the display. It doesn't matter how big or small the array is, rabbit count is what's keeping sort of tabs about how many rabbits. It's a sensible name. I think for this demo I'll probably just take the top 30 or whatever, just to keep life easy. But if you end up taking random rabbits from the old full warren, then don't forget you need to compress those rabbits afterwards. If at this stage you're thinking, what on earth is compressed rabbits, you need to have a good look at the warren class, find that compress rabbits method, step through it, and make sure you understand what it's doing to the rabbits array, because that's got dry run written all over it. So what else we need to do to the Warren class? Oh yeah, we need to get the rabbits back into the new Warren. So it's still in the Warren class. It will be invoked one in one object, one in another, but it's still the same class. So we need to create a new version of the instantiation class, the sub-new if you're in VB. And we're going to stick in a parameter so it accepts that transferred rabbits array and changes the rabbit count. If we want to have it so that rabbit, so the full Warren, which is now not full, when it gets full will spawn again, we will need to make a small change to the create new Warren. Let's see how long this video is to see if we bother with that. That's a nicety, and you'd be told in an exam if they wanted you to do that. In the simulation class, and hopefully you're still following me, we will need to alter create new Warren so that it can handle this get transferred rabbits from the full Warren and pass it to the new Warren. So effectively it's going to call the two methods we just created. Need to be careful that it will set up the new landscape correctly, which is why we're going to change or overload it. I mean, I guess we could create a completely new method. Yeah. And we ought to have some output, otherwise it's going to be a real pain in the neck to test it. As I say, I could have something called transfer new Warren and call that. That'd be a perfectly sensible thing to do. Either or doesn't really make a difference. So now I've overviewed everything. Let's have a quick look at this first thing. Get the rabbits that need to be transferred. That's what we're going to play with first. And over the next couple of minutes, you're going to see how to create that method. Right, let's get going. So let's create a new function. Get transferred rabbits, because of course when we call it, it's going to be Warren dot get transferred rabbits, so it will make sense. And just so we're clear about the syntax, it's returning rabbit. That means an array. It's returning an array of rabbit. This just denotes that we haven't got any parameters being passed. I'm a bit of a fan of having temporary variables to play with inside my functions, and then I can just get them exactly as I want them, debug it really easily, and just return that at the end. So let's do that. I've called my thing rabbits wanting to leave. I don't suppose the rabbit's really cognizant, but might as well call them something else. And I've decided just to fix it at 30. It would be dead easy for you to pick a random value. It would be dead easy for you to pick a random value based on the variability. But let's keep it really simple. For now, we're going to take 30 rabbits. In actual fact, to be really lazy, we're just going to take the 30 rabbits that are in the 30 highest array indices. Again, you want to pick random rabbits. There's other code that allows you to have a look at that. I might do a little extension video. Let's keep it simple. So we're going to just have a for loop that iterates 30 times, and all we're going to do is say that the first 30 elements of rabbits want to leave gets assigned to the top 30 elements of rabbits. Just need to be a little bit careful that rabbits actually gets given 99 as its highest indice in VB, but only ever fills up to 98 because of the 0th start. So it's starts at 0 with 99 rabbits, and that means the 99th one is empty. I'm not 100% sure how the other programming languages handle that, but certainly how it is in VB. So we've now assigned the top 30 rabbits to our array, our new array. So we ought to destroy those top 30 rabbits just by making them into nothing. And now we need to make sure that rabbit count will also be altered. I think that's our checklist. Don't need to compress the rabbits, because I'm not taking random ones. If I was taking random ones from the warren, I would then need to execute compress rabbits. And I think that is everything. We're going to get returned, and I think that's it. So let's move on. We've now created a method that will pump out our transferred rabbits. We now need to create a new sub-procedure, which will be the instantiation, and that will take in these transferred rabbits when a new warren is created on spawning. Okie doke, so we're in class warren still. We've got our get transferred rabbits. There are currently a couple of instantiation methods, and these are overloaded. They've got different number of parameters. Look, they follow a set pattern. We're going to follow that set pattern. I think if I were you, I'd be tempted to do a bit of copy and pasting and making an edit, but we're going to start from scratch. So, hello, what's going on here? Okay, so I've just copied and pasted one of the program interfaces for that subnew, and I'm going to add an extra parameter. This means it's now allowed to be overloaded, because even though this is 2 parameters and this is 2 parameters, this is of a different type, so that means it's allowed. Crucially, it's as array of rabbit, transferred rabbits. Could be called whatever I wanted to, but it seems to make sense to keep things the same. Oops, wrong one. This is how we're setting up the array of rabbits in a new warren, so it seems to make sense to use exactly the same syntax. There are other syntaxes that work. You need to understand that that basically means create an array of type rabbit with that many elements. It's not passing any parameters to the new instantiation method. What's going on? There we go. I've now got a for loop which is going to go from 0 through to the length of transferred rabbits. I mean, I know that's 30, so I could just set this through 0.29. That would be fine. But because we might change that later on, it seems to make sense to say whatever the length of this array is that gets passed in, we will iterate through every single element in it. Then, as you probably guessed, all we've got to do is assign each rabbit from each element of transferred rabbits through to rabbits. And don't forget, rabbits is the array that holds the rabbits in a warren. Reasonably sensible name. We need to make sure that we keep tabs on rabbit count, because otherwise we won't have a correct number of rabbits shown. Oops. And that, believe it or not, is that. Make sure we give the instantiation method the rabbits. Make sure we set up the array so that we can have a maximum of 99 rabbits later on, and then simply have an array that transfers each rabbit across and, crucially, updates rabbit count. We've now finished with warren. We've got our get transferred rabbits, which will get the rabbits out of the old warren, and we've got our new instantiation method, which will get our transferred rabbits into the new warren. If we did want to make that final little quick change, it's down here where we go, need to create new warren, and I could just bin and not other already spread and just remove that. So if we wanted to, we're not going to. Not for the moment. So, have we ticked everything else off our list? Yes, we have. Let's move on to the simulation class. We need to change create new warren. I think I'm just going to overload it because that's nice and simple, because it allows me to do a copy and paste job. So let's do this live. Let's get our create new warren, Control C, Control V, and we're going to need to make sure that this is different in somehow. We can't have them exactly the same, so why don't we pass it transferred rabbits. In fact, we could be funny. Transferred rabbits. I ought to credit James for that rubbish joke. An array of rabbit. Happy? Now then, we're still going to make sure we've got this loop that's looking through to make sure the place that we're going to place our new warren is not already got a warren in it. So that's essential. We'll change this in a moment, but this is the crucial bit. Rather than calling this new warren, we need to call it with this. Transferred. Oh, I forgot to call it transferred rabbits after that silly joke. Transferred rabbits. Transferred rabbits. So we're passing this into here. Okay. I'm just going to make a quick change to that. Whoops, what have I just done? Never do this live. Just going to make a quick change to this. Joy. So we can see what's going on. I've just basically said this how many rabbits have been transferred. And you know what? I'm going to get rid of the show detail for the moment. Just going to comment it out. It's going to make our testing easier in a moment. We'll have to put that back in later on. So, create new warren, transferred rabbits, blah, blah, blah. Wonderful. We've made those changes. Okay. We do need to make one more change to the simulation class. Clearly, we've now got this create new warren. When we scroll back up to advanced time period and we actually look at where create new warren is been, this is not calling this create new warren. It is still calling the original create new warren. So let's get rid of that and make a quick change. Okay, let's get rid of that and make a quick change. And let's make sure you understand what this is. Still got create new warren, but we need to pass into it transferred rabbits. Where can we get those transferred rabbits from? By calling the get transferred rabbits method. This will call the instantiation. This is where we're getting it from. This pulls the data out of the old warren. This will stick it into the new warren. And I'll put another right line in just so we can see that definitely the right warren is going to lose some rabbits. That should now be finished. Let's test it. So we're going to, I've set up a new default landscape, so let's just step through a few times, keep your eyes open. Got a couple that are getting close. Right, so we've got two that are on 99. Nothing's happened yet, hopefully this time. Brilliant. New warren has been created at 11:10. 11:10. And another one has been created at 14:13, which is that one. And 1-1 lost it, and 13-4 lost it. 13-4 lost it. Okay. Now the reason why this and this aren't at, sorry, this and this warren aren't showing 30 is because, of course, after we've transferred those rabbits, those warrens do undergo a generation because we transfer at the start of the time period. So those rabbits breed and get eaten and do whatever else, or they won't get eaten at the moment because there's no foxes. So that is perfectly acceptable to see that these aren't a predictable number. If you have any questions about this code, or you think I've made a mistake, or anything else, if you don't understand the concept, then please feel free to ask questions in the comment section. If you've got any other suggestions about code that I might produce, or anything you'd like me to run over, again, feel free to ask. If I've got time, I'll try and do it. Hope you've enjoyed this. Hopefully you now understand about Magic Rabbits, and I look forward to doing the next programming exam solution tutorial.